Hi, I'm Dr. Kuldeep Kavta, a postdoctoral researcher at Transport and Planning Department at TU Delft. Today I'm going to present you my research which looks at consumers' willingness to improve the safety of food delivery riders. So we are looking at people who order food online and their willingness to contribute to improve the safety of delivery riders. And the team involved in this research consisted of myself, Professor Shadi Sarifazadeh, and Professor Gonzalo Correa. So we all know that food delivery business has been growing very rapidly, and especially after the COVID times, we have seen a huge jump in the number of people ordering food online. But it also has increased the number of crashes on roads involving food delivery riders. An estimate suggests that around 25 to 35% of riders have experienced some kind of crashes in the past. And these crashes could occur due to various reasons. And one of the reasons in this particular case could be the time-bound nature of the food delivery business. When these crashes occur, it's not that the riders are only affected parties, but they get involved in crash with other citizens who are using the same road space infrastructure. This also causes traffic disruptions and pressure on the emergency services such as ambulances. Now if we look at the overall picture, what's happening here is someone is ordering food online sitting at their home, and they are not aware of the consequence of ordering food online. So the riders who are getting involved in the crash, they are getting involved in crash with other citizens who have nothing to do with the ordering food online. So it's a classic case of negative externalities where one party is responsible for creating this negative externality and the other party is facing the consequence of it. In past, in the literature as well as in practice, it has been seen that when consumers are made aware of this negative externality, then there could be a shift in their behavior. Some of the examples are shown on the screen. We can see when people book flights, sometimes we see the amount of emission that the flight would be causing. Now this is to make you aware about the consequence of choosing that particular flight. Similarly, we see this in supermarkets where some fruits are labeled as organic to make you aware about the consequence of going for the inorganic food on the environment. So we thought of using the same concept but applying it in the context of safety of food delivery riders. Now to study the consumer's behavior in our case, we had to do a survey. So we designed a survey, and this survey, the main part of the survey was a stated preference experiment where we asked the respondents, the consumers, to choose between different cuisines. So they were given options of different cuisines. This was a hypothetical choice set, and these cuisines were shown by the attributes such as the cost, the delivery charge, and the delivery time. These are the standard things that you see when you order a food online on any of the platforms. But in addition to this, we also included one more attribute that captures the risk that the riders might face while delivering that particular cuisine. That risk is shown in percentage as well as through labels to make it easier for respondents to understand the kind of risk that the riders might face. And this survey was conducted in 2 cities, Amsterdam in the Netherlands and Copenhagen in Denmark. And we used actually 350 samples in our modeling. Now going to the modeling approach, we adopted a hybrid latent class model. And this model postulates that consumers or the respondents can be categorized in different classes, and each class will have their own set of parameters to show how much they are sensitive towards different attributes of the cuisine, be it delivery cost, delivery time, or the risk for the riders. Now moving on to the results. The first thing that we determined was the number of classes. So we tried making models with 2 class, 3 class, 4 class and so on. But we found that the the 2 class model was fitting the data best in terms of BIC values, and hence we went for the 2 class model. Then you see the table showing the factors that are responsible for determining whether a person will fall in class 1 or class 2. These factors include age, education, and the score for the insensitivity towards the road safety. Now, based on the proportion of people falling in different classes, we called one class as class IRS and the other class as class SRS. The class SRS means the class which is sensitive towards road safety. And what we found is people who are young, who are highly educated, and who have sensitivity towards the road safety in general, they tend to fall into this class of class SRS. Now moving on to the full model, now we have parameters, estimated parameters for both the classes. What we found is that the cost of the meal and delivery time, both factors are statistically significant in influencing the decision of choosing the cuisine, and this is true for both the classes. But when we look at the safety risk for riders, only class SRS is showing a statistically significant impact. So which means the class which is sensitive towards the road safety is also sensitive towards the safety of riders, whereas the class IRS is not getting affected with this information about risk for the riders. We also found an interaction term to be significant. What it says is that within the class SRS, there could be people who are more concerned about riders, and there could be people who are less concerned about the riders. And the way they react to the information about risk would be different. And this difference is being captured by this interaction term that you see in the table. Now using the estimated parameters, we calculated the marginal rates of substitution or willingness to pay for both the classes. And what we found is only class SRS is having a statistically significant willingness to pay values. That means that people in class SRS, they are willing to wait longer or willing to pay more if that improves the safety of riders. And these values are shown in the table. For example, the class SRS on an average is willing to wait 18 minutes more if it improves the safety of riders by 10%. Now, these values were used to compare with one of our previous studies where we looked at the riders' willingness to pay. So, we had asked riders how much they are willing to travel longer if it improves their safety. And when we compare the willingness to pay of consumers and willingness to pay of riders, we get some interesting results. We see that consumers in class SRS, they are willing to wait way longer than what riders are willing to travel to improve the safety. Now, based on this comparison of willingness to pay values of consumers and riders, we have some suggestions from the study. The first recommendation is that actually there is no need to rush for the riders, because our studies show that there is a section of consumer who is willing to wait longer and also pay more if that improves the safety of riders, given that they are made aware of the risk that the riders possess. The second thing is that platforms should invest in knowing their consumers more, because it is generally assumed that consumers only care for quick delivery and also low cost. But what our study found that actually they are also willing to contribute when things like safety and well-being are concerned. So probably platforms should invest more in knowing their consumers better and use this information in devising solutions that is tailor-made to improve the safety and well-being of the riders. This study has been already communicated and it's now available as preprint. The QR code is available. You can scan it to access the full paper. And the previous study about riders' behavior that we did is also now available online, and you can check the Transportation Research Part C paper for the rider behavior study. Thank you. You can have a look at SumLab website and the Synergy project website to get more information about the research that is going on in the online food delivery systems. Thank you.